Chapter 2.4, exercises 25 through 30, page 224. This is section 2.4 again, where we're working with real zeros of polynomial functions. In exercises 25 to 26, use the graph to guess possible linear factors of f of x, then completely factor f of x with the aid of synthetic division. So we'll get this original equation here plus a graph of that function. And so what we're looking for is the zeros of this function, and we're going to kind of work backwards to find the factoring of this polynomial function here. 5x cubed minus 7x squared minus 49x plus 51. So the first thing we're going to do is locate the zeros. And so we see a zero over here. I'm going to circle them, just kind of label them. So this kind of looks like here x equals negative 3. And then over here at the right of the y-axis we have x equals 1. And then this last zero here, we're somewhere between 3 and 4, but we're not sure what. So that's going to be our question mark. But to completely factor, we're going to have to find out what that third zero is on the right. Well, what we're going to do is we're going to say, I'm just going to write here next to it to guess possible linear factors. If we were to guess, we would say for this x minus 3, if x equals negative 3, then to set this equal to 0, let's go ahead. If we have x equals negative 3, if we set the right side equal to 0, we have to add 3 to both sides here, plus 3. So we have x plus 3 is equal to 0. So if we had to guess, we would say x plus 3 would be one of those factors, right? And then the next one, we have x equals 1. Well, if we set this equal to 0, we have to subtract 1. So we're going to have x minus 1 equals 0. So another factor might be x minus 1. And then we're going to have a third linear factor to get x cubed. We have to have a third linear factor if this thing is factorable. It looks like it is. So let's go ahead and use synthetic division. See, so we're going to take this equation here, this function, and we're going to use this x equals 1 for our 0. We put this value of the 0 right here. We're going to, because 1 would probably makes it a little easier. That's the only reason for that. So if we take our, we have 5x cubed. We have minus 7x squared. We have minus 49x plus 51. And that's one way we know if we've chosen correctly, if the thing comes out with no remainder. So anyway, we bring down the 5, as in 5x squared. So 1 times 5 is 5. Negative 7 plus 5 is negative 2. Negative 2 times 1, negative 2 is going to be negative 2. And negative 49 minus 2 is going to be negative 51. And 1 times negative 51 is negative 51. So our remainder is 0. So we're going to have 5x minus 5x squared, excuse me, minus 2x minus 51. And so we're going to go ahead and take this second one and divide it by this x x plus 3, the factor of x plus 3. So to do that, we're going to take minus, we got to put negative 3 here, we got to put the value of the 0, and we're going to put 5x squared minus 2x minus 51. And working that out, we come down to 5x, 5 is in 5x, and negative 3 times 5 is negative 17, no, negative 15, excuse me. 5 and negative 15, and negative 2 plus negative 15 is negative 17. Negative 3 times negative 17 is positive 51, so we get a 0 here. So our third factor is 5x minus 17. So we're going to put 5x minus 17, which is what we have left. And so that that last 0 is going to have to be 5x minus 17 is equal to 0. If we add 17, we have 5x equals 17. And dividing by 5, we have x equals 17 over 5, which is going to be decimalized, I think it's 3.4. Anyway, that looks like it's about right between 3 and 4, so that checks. So this is our complete factoring using synthetic division. So we start out with the obvious ones first and kind of work our way through that. Next, we come to the next autumn problem. The exercise is 27 to 30. Find the polynomial function with leading coefficient 2 that has the given degree in zeros. Degree equals 3, and we have negative 2, 1, and 4 zeros. So we find our zeros by putting x equals negative 2. We have x equals 1, and x equals 4. And solving for 0 on one side, we're going to have x plus 2 is equal to 0. We're going to have x minus 1 equals 0. We had to subtract 1. Finally, we're going to have x minus 4 is equal to 0. So that's going to be essentially our factors. So we'll say f of x equals, we're going to have quantity x plus 2 times quantity x minus 1 times quantity x minus 4. And then we need a leading coefficient of 2, right? So we'll put 2 out front like this, and that'll multiply 2 by everything, and that's going to end up, we're going to end up with 2x cubed, right? That'll be our first term. And then we can go ahead, if we want a polynomial function in standard form, all we need to do is multiply all this together. So if we just take, let's just take x minus, we'll take the first 2 together. We'll say x plus 2 times x minus 1. So x plus 2, x minus 1, we get x squared plus 2x minus x minus 2. So we're going to get 2x minus x. We're going to get x squared plus x, and then we're going to have minus 2. And that's going to be, we're going to make a box to multiply this together, and we're going to multiply by our last factor here, which is going to be x minus 4. So we put x minus 4, and x times x squared, that's going to be x cubed, and then x times x is x squared, x times negative 2 is negative 2x, and then the lower one we have minus 4x squared. We have negative 4 times x is going to be negative 4x, or minus 4x, and negative 4 times negative 2 is going to be 8. So we work all this together, we're going to have combined terms here in the squareds, negative 4x squared plus 2x, and then negative 4x minus 2x. So we're going to have x squared, we have x to the third power, and we're going to have negative 4x squared plus x squared will be minus 3x squared, and negative 4x minus 2x could be minus 6x, and we're going to have plus 8. And we're going to multiply everything by 2 to get our leading coefficient of 2. So we're going to get 2x cubed minus 6x squared. Let's see, 2 times negative 6 will be minus 12x, and then 2 times 8 will be plus 16. So that's it all worked out. So we have, I'm going to write this up in purple here, 2x squared, 2x cubed, minus 6x squared, minus 12x, plus 16. And we can also check using our calculator to see if we have the same zeros here. We'll do that. We're going to get a graph here. We're going to have 2x cubed minus, was it 6? Minus 6x squared minus 12x plus 16. Minus 12x plus 16. And we graph this, we get a 0 of negative 2, 1, and 4. So negative 2, 1, and 4 meets the criterion. See? Negative 2, 1, and 4. Check, check, check. So this is going to be our correct answer right here. Now the next odd number problem, which is 29. We have degree equals 3 with 2 1/2 and 3/2 zeros. So we have x equals 3. That's one of our zeros. We have, no, I got that wrong. X equals 2 is 0. X equals 2, its degree equals 3. The zeros are 2. X equals 1/2. And x equals 3/2. So to solve this, we would say, we would solve for 0, so x minus 2 is going to be equal to 0. We have, if we subtract 1/2 from both sides, we're going to get x minus 1/2 is equal to 0. And finally, we're going to get x minus 3/2 is equal to 0. So we can multiply all these together. And to do that, we would take, I'm just trying to think of the easiest way to do this, because we need a degree equals 3 and coefficient 2. So let's just go ahead and multiply. And what I'm going to do is, I think I can make this a little easier if I'm going to take this last function here, and if we multiply this equation here by 2, this one on the right, what are we going to get? We're going to multiply by 2. We're going to get 2x, and then we're going to have minus 3 is equal to 0. So let's go ahead and do that. I'm going to use this equation, be maybe a little easier, I hope. We put 2x minus 3, and on the left one we're going to have x minus 2. And multiplying these together, we get 2x squared, and then minus 3x. We have minus 4x in the lower left, and the lower right we have plus 6. And combining our like terms in this, we have 2x squared minus 7x and plus 6. All right, so with that, we're going to multiply the last by this x minus 1/2, this last factor. So So we have x and negative 1/2. And so if we multiply x times 2x cubed, we're going to get, or 2x squared, we're going to get 2x cubed. X times negative 7x is minus 7x squared. X times 6 is 6x. Negative 1/2 times 2x squared is going to be minus, so negative 1/2 times 2 is 1, so we have minus x squared. We're going to have negative 1/2 times negative 7x. We're going to get 7 over 2 x, and the last one, negative 1/2 times 6, is going to be negative 3. And so just working all this together, we're going to have negative x squared minus 7x, and then 7/2 x plus 6x. And so that's going to be 2x to the third power minus 8x squared, and then 7x plus 6, 7/2 x, I'm going to write this on the right side, 7/2 x plus 6x is the same as 7/2 x plus 12x, 12/2 x, right? So we're going to get 19/2 x, right? So we're going to have, that's going to be plus 19 over 2x. In fact, that's going to be 9.5x, right, if we decimalize this. And finally, we're going to have minus 3. And so all we have to do is really check. We have a leading coefficient of 2. So let's go to our graphing calculator and check this. Make sure everything looks good. So Control I. We have add graph. We have 2x cubed. And we have, let's see what we have here. We have minus 8x squared, so we put in, oops, yeah, there we go, minus 8x squared. We're going to have minus, or is it plus? Plus 9.5x minus 3. Minus 3. We'll see if we get all the roots we need here. Yeah, they're kind of hard to see. We can kind of, if we go to the table view, we can look at this a little more. Analyze graph, not the table view, but analyze graph. Let's go to window zoom. We're going to go to window settings, and we're going to go to X-min. We're going to make this 0. X-max, we're going to make this 2. And Y-min, Y-max, we're going to make these -1, comma 1. And then get down here, and we have, okay, let's just analyze the zeros. We have menu, analyze graph, 0. So we have, that's a 0 of 1/2. Next one, menu, analyze graph, 0. We go left, right. So 0 is 1.5, which is 3/2. And the last 0 here should be about 2, right? So 0.5. So we have 2, 1/2, and 3 over 2. Let's check this out, see what we have here. Let's see. 2, 1/2, 3 over f. So it checks out. So that's going to be our function. So f of x equals, we have all this, and we can make that 19 over 2. We can just write that as 9.5. So anyway, good luck on these other problems, the even number problems, and I thank you for viewing.